Today we're going to be graphing logarithmic functions, and I want to make it simple for you. So we have what may look like to be a complicated equation, but really the key is what's in parentheses right here. That's going to help us find the asymptote right away. So what we want to do is take that quantity, whatever's inside the parentheses, and we want to make it equal to 0. So we have negative x minus 3 is equal to 0. So we just simply solve for x here. So I'll go ahead and add 3 to both sides. And that's going to give me a negative x is equal to 3. However, I want the x to be positive, so I'm going to have to multiply by, let's say, a negative 1. And that's going to give me the positive x I want. So x is equal to negative 3. So that's actually my asymptote. So I'm going to kind of keep that, and we'll graph that a little bit later. Okay, again, the key is still what's inside the parentheses. That's going to help generate the x values that we want. So we're going to make an xy table, and we've got to choose the points that we want for that xy table. And the first point that I want is, well, first of all, let's look at that. It would be nice if we could be working with log base 4 of 1. And if we could generate what's inside the parentheses to equal 1, what that does for us is log base 4 of 1 actually equals 0. So what that does, it makes this entire quantity equal to 0. So all we have to do is take what's inside the parentheses, which is negative x minus 3, and we want that to equal 1 somehow. So all we have to do is solve for x. So I'll go ahead and solve for x, add 3 to both sides, and I end up with a negative x is equal to 4. Negative x is equal to 4 because these cancel out. And again, I want a positive x, so my positive x would equal a negative 4. So negative 4 is actually the value that we want. I'll go ahead and box that right there. What happens when that's a negative 4 in there, what we get in here is a 1. So all of this becomes 0. 0 times 3 is 0, and so y equals negative 4. It's just a coincidence that they both equal negative 4 in this case. So that's my y value. So I need one more x value. All I have to do now is it would be nice if we could get this log base 4. If it was log base 4 of 4, that would be very convenient because that actually equals 1. That actually equals 1. So if we could generate the negative x minus 3, if we could find an x value that would cause this to equal a 4, this whole quantity would equal 1. So again, all we have to do really is take negative x minus 3, and this time we want it to equal 4. So we want that to equal 4. So we'll go ahead and add 3 to both sides, and we end up with negative x is equal to 7. However, that's a negative x. So we keep solving, and we're going to end up with positive x is equal to a negative 7. So that's actually the x value we want. And I'll go ahead and just circle that right here. So when we put a negative 7 in here, what we were trying to do is, going back, we were trying to get this quantity to equal a 4, and it does. And if it equals a 4, then this entire quantity log base 4 of 4 equals 1. 1 times 3 is 3. 3 minus 4 is negative 1. So then my y value becomes negative 1. And now I have everything I need to make my graph. So I'll just make a xy axis. Pull that, just kind of make some room over here. And we'll make an x and y axis. And I know I have to go down to negative 7. So 1, 2, 3, 4, 5, 6, 7. And actually I made a mistake. It's not the y values I need to be negative 7. It's the negative 7s on the x. 1, 2, 3, 4, 5, 6, 7. Because my equation of the asymptote is x equals negative 3. And that's going to be the asymptote there. So let me go ahead and graph that. All right. So my 2 points are negative 4, negative 4. I'll graph those. Negative 4, negative 4. So that would be right about here. And the other point is negative 7, negative 1, which is here. And that's enough because now I know the graph is going to slowly rise to the left there. And going down to the right, it will never cross the asymptote. But it'll just what we call hug the asymptote. There's my graph of the logarithm. And that's how easy that is.